Hello and welcome back to another IB Math speedrun with me, Vince. In this speedrun, we're going to be going through division and reciprocals of complex numbers in polar form. So let's jump right in. So using the properties of multiplication, we know that 1 over a complex number or its reciprocal is actually equal to 1 over its modulus, CIS, 2 pi minus theta, or in other words, negative theta. So this is the reciprocal of a complex number, and it's pretty easily proved. And so we can use this then to define division. So if we are dividing two complex numbers in polar form, this is equal to the modulus of the first one over the modulus of the second one, CIS, theta 1 minus theta 2. So when we are dividing complex numbers, we divide their modulus and subtract their arguments. Of course, z2 is not equal to 0 and r2 is not equal to 0. So yeah, with that being said, let's jump into some questions. So the first question we need to find is, I guess we'll just do the odd ones. So we're given that z1 is equal to 3 CIS pi over 4. z2 is equal to 4 CIS 5 pi over 3. And z3 is equal to 5 CIS 7 pi over 6. So first we need to find z1 over z2. And next we need to find z1 over z2 times z3. So we'll find this one first. So z1 over z2. So again, if we are dividing two complex numbers, we need to divide their components. So we have 3/4. And then we have to subtract their arguments. So we have pi over 4 minus 5 pi over 3. So what is pi over 4 minus 5 pi over 3? So this is going to be 3 minus 20, which is negative 17 pi over 12. Which, I mean, we can also write this as 24 minus 17 is equal to 7, so this is 7 pi over 12. Nice. Yep. Okay, and then for the next one, we have z1 over z2 times z3. So we can do this two ways. We can divide z1 by z2 first and then divide by z3. And that's probably the easier way. So this would be equal, since we already have z1 divided by z2, we can simply divide this number by z3. So this is going to be equal to 3 over 20. CIS, and then 7 pi over 12 minus 7 pi over 6 is negative 7 pi over 12. So that should be our answer. Yeah, very nice. Okay. So now on to the next question. And the next question is, let z1 is equal to 1 plus I, and z2 is equal to 1 minus 3i, square root 3i. So we need to find the following. We need to find z1 over z2 and 1 over z1 z2. But we need to find it in Euler's form. Okay. So let's convert these into Euler's form. So 1 plus I is equal to, so we have sine theta is equal to 1, cosine theta is equal to 1, so we have tangent theta is equal to 1, theta is equal to square root 2 over 2. Sorry, I mean r. So tan theta is 1, theta is not square root 2 over 2, oops. Theta is equal to pi over 2. So sine pi over 4, sorry. So we have r is equal to root 2. So this is z1 is equal to root 2 e to the I pi over 4 And then for 1 minus square root 3 pi, so we have tan theta is equal to negative root 3. So we have theta is equal to, what would this be? This would be equal to 2/3, 2 pi over 3. So this is, and then we have 1 for cosine theta. So this is 2 times 2e to the I 2 pi over 3. And so if we're dividing these, we can simply just divide them now, like normally. So if we have, this is going to be z1 over z2 will equal square root 2 over 2 times e to the I pi over 4 minus e to the I pi 2 over 3. So this is ei to the pi over 4 minus 2 pi over 3. So 3 pi minus 8 pi, so negative 5 pi over 12. Ah, wait, cosine is positive. Oh, so I've messed this up, sorry. This is 2e to the I, but instead, theta, because tangent theta must be equal to negative root 3. So this is actually equal to 5 pi over 3, or negative pi over 3. Since we have sine is negative and cosine is positive. Just remember that there are 2 tan values for each rotation. So this is actually I to the 7 pi over 12, since we're going pi over 4 plus pi over 3. So we have, is this 7 or 5? 7, yeah. And then, so next we need to find 1 over z1, z2, which we can find as we'll find z1, z2 first. So z1, z2 is equal to 2 square root 2 e to the negative I pi over 12. So we have 1 over z1, z2 is equal to 1 over 2 square root 2, which is equal to square root 2 over 4 e to the I pi over 12, since we invert the negative symbol here. Okay, so that's all good. And then so we need to express, okay, so that's the next question already. So we need to express in polar form 3 over 2 plus 2i. We'll do this one first. So we need to express this in polar form. So how do we do this? Well, we can simply convert both of these numbers into polar form. So 3 in polar form is equal to 3 cis 0. Yeah, and then 2 plus 2i, well, we have tan theta, so this must be theta pi over 4, so it's going to be, I think it's 2 root 2. CIS pi over 4, since cosine pi over 4 is equal to square root 2 over 2. So yeah, it should be 2 square root 2. And so now we need to simply divide the two numbers. So we get 3 over 2 square root 2 times CIS negative pi over 4. Since we need to subtract pi over 4 from 0. Yep, that's correct. Actually, wait. Yeah, that's correct. And then, so finally, we need to find the value of square root 15 minus square root 5i over square root 2 plus square root 6i. So let's find the value of each of these polar numbers. So square root 15 minus square root 5i, so we have tan theta is equal to negative square root 5 over square root 15, which is equal to negative 1 over square root 3. And this is, well, we have negative sign, so this looks like negative pi over 6. So we have CIS negative pi over 6. So sine negative pi over 6 is 1/2. So we need to multiply this by 5 square root 2. Sorry, 2 square root 5, I mean. And then divide this by, well, what is this? So we have tan theta is equal to square root 3. So theta must equal pi over 3. So we have CIS pi over 3. Sine pi over 3 is square root 3 over 2. So we need to multiply this by 2 square root 2, I think. So now we can divide this number. So we can simply cancel out that. So we have, let's multiply both top and bottom by square root 2. So we have 2 and this is 10. So we have equal to square root 10 over 2 times CIS negative pi over 6 minus pi over 3, which is equal to negative pi over 2. So yeah, that should be the correct answer. So that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one. See you then.